Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 28, 2025, just 2 days ago. This paper tackles a critical limitation of current LLMs, their static nature, proposing a paradigm shift towards agents that can learn and adapt in real time. The paper is titled A Survey of Self-Evolving Agents, On Path to Artificial Superintelligence, and it lays out a fascinating roadmap for how we might actually get there. It systematically reviews this emerging field by breaking down the problem into what, when, and how these agents can evolve. Also, the authors shared their GitHub repository, and it's a real treasure trove for this topic. You won't find a direct implementation, but you will find a comprehensive, organized collection of all the key papers they surveyed, categorized by subject. It's a perfect starting point for a deep dive. Alright, so the paper kicks off with a great conceptual figure that really sets the stage. It shows a trajectory of AI development, starting with the LLMs we know today, like GPT-4, which are great at language. Then, it moves to what they call foundation agents. These are a step up. They can use tools and plan tasks, but the real focus is the next step. Self-evolving agents. These agents don't just execute plans. They actually learn from feedback and experience, adapting over time. This progression is the path toward artificial superintelligence, or ASI. Building on that idea, the paper structure itself gives us a fantastic roadmap. It's organized around 3 foundational questions: what to evolve, when to evolve, and how. For what, they explore changing the agent's models, its memory, and even its ability to create new tools. For when, they make a key distinction between intra-test time evolution, which is adapting in real time during a task, and inter-test time evolution, which is learning between tasks, and how it covers the specific algorithms that drive this learning. This framework really helps organize this complex topic. Okay, so this next figure gives us a fantastic taxonomy that visualizes that exact structure. It branches out from a central self-evolving agent into those key dimensions: what, when, how, and also where to evolve. Under when, for example, it shows how agents can adapt using different machine learning techniques. These include in-context learning, or ICL, where the model learns from examples given directly in its prompt. Another is supervised fine-tuning, which involves retraining the model on new labeled data, and also reinforcement learning, which is learning through trial and error based on rewards. To really highlight what makes these agents so different, this table compares them to other AI paradigms. We see things like curriculum learning, where models learn from easy tasks before hard ones, and lifelong learning, which focuses on learning new information without forgetting old knowledge. Looking at the columns, it's clear that only self-evolving agents can do it all. They can evolve their context and tools, actively explore, and even change their own structure. But the most important distinction is that they are the only ones capable of self-reflection and evaluation. Alright, so diving deeper into the how of evolution, this table compares the main families of self-evolution methods. We see reward-based, imitation-based, and population-based approaches, and it really breaks down their trade-offs. For instance, imitation learning is highly sample efficient, which means it can learn from less data, but its success depends entirely on the quality of the demonstrations. In contrast, reward-based methods are very scalable with automation, but can be sensitive to how you design the rewards. It shows there's no single best method, just different tools for different challenges. So, with all these different methods for creating self-evolving agents, the next logical question is, how do we even measure if they're working well? This next diagram lays out a new framework for evaluation. On one side, we have the core goals, things like adaptivity, safety, and retention. Retention is especially key. It measures if the agent can learn new things without catastrophic forgetting, which is when new knowledge erases old information. Then, on the other side, we see a shift in the evaluation paradigm itself, moving from static, one-off tests to long-horizon assessments that track learning over time. So this new evaluation paradigm really brings it all together. This survey provides a crucial roadmap for moving from static models to truly adaptive agents, organizing this complex field around what, when, and how these systems evolve. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.